Hey there, welcome back. So I'd like to share a quick insight with you, CMTEQ channel members, that is regarding the orientations of these radial inductors. This is something that most designers overlook when designing power electronics circuit, and how these inductors orientation can dramatically impact EMI performance in power electronic circuit. We'll basically be comparing the vertical and horizontal mounting, and I'll show you how each one of them influence the magnetic field and radiated noise around the switching node of your buck or boost converter. Now, I'm sure that most of us have a basic understanding of how a boost or buck converter work. I've released a tutorial explaining in detail how these circuits operate. Now, having said that, we know that inductors store energy in the form of magnetic field whenever there is a current that flows through it, especially pulsed current. Like in this circuit here, we've got a PWM that induces a pulse current in this node here. Now, this creates the effect of a magnetic field around the inductor that expands and collapses very rapidly. Now, in PCB layout, this point here in power electronic circuit, the switching node, is already a high dV/dt region, basically meaning it's radiating electrical noise because of the switching. Now, if your inductors terminal are vertically oriented like this one right here, the node that it forms here, this node, will have a field, right? That field will also extend into the Z axis, right, of your PCB. Okay, now this will go out of the board's plane, which now can act like an antenna. Okay, and the result of that, it will increase the EMI emission into your PCB area. By the way, if you find this electronic design insight useful, please make sure you give it a thumbs up and subscribe to CMTEQ channel if you'd like to see more power electronic switching converters design insight. So in the vertical orientations like this one here, and also in these PCB representation that we've got here, we can see that the coil's magnetic field lines, they basically loop, as you can see here, the loop sideways, okay, and forming quite a tall magnetic bubble that radiate outward and upward, okay, which the effect is then that there is an increase in the coupling between the inductor and the nearby traces or components. As you can see, these are PCB, and you've got all these PCB tracks or traces that are all over the places depending on how the PCB was routed. So the orientation of that field is causing quite a higher coupling between the inductors and the PCB traces. And this is especially high for any PCB or component that is connected near the switching or routed near the switching node here, because that is where most of the high dV and dt noises are happening. All the switching noises are happening at this point here. So which means any components or PCB traces that are coming or crossing around here, they will have magnetic field coupling that's going to cut through them. So which means your voltage lines, your ground loops, and all of those, they're going to suffer the consequences of that noise. Now, if you'd like to watch the full 12 to 13 minute deep dive in these power electronics switching converters inductor orientations, it is available for channel members. The channel membership start at only $2 per month. So if you want to find out more, click the join button below, and I'll see you on the other side. Thank you so very much for the support.